Well, welcome to Smart Futures webcast. This is episode 11. Thanks for everybody for joining. And today we have the honor of having Kevin Keeney from Elastic. Welcome, Kevin.
Hey, thanks, Jim. Thanks for having me on. Appreciate being here.
And we thought maybe for the first couple of minutes, maybe give some background and what you've been doing in the government for the last few years.
Yeah, absolutely. Entered government service through the military. I was an active duty Army guy and transitioned to the Army Guard. And that's where I really kind of found my knack for technology and my interest in it. Pretty traditional career path, sysadmin, moved up the ranks, running data centers, building and designing data centers across different DoD organizations. But as a traditional guardsman, I got exposed to IO, information operations, information warfare. And that was my initial exposure into cyber, and then that paid off many years later as I started doing that as a drilling guardsman and started impacting my full-time career for sure. So kind of been a little bit of everything. Been in uniform, been a GSer, been a contractor. Now I lead the Army mission support team here at Elastic and supporting the Army business unit.
Cool. So can you maybe give a little summary of like where Elastic is today in not just Army, but across DoD and kind of what the use cases are? I've run into a lot of people that just have never heard of Elastic,
Sure.
or what its use cases or what they're using in the commercial world for it.
Yeah, absolutely. So Elastic was adopted early within the DoD, within the intelligence community, back when it was very much a developer tool. So a lot of systems are built upon it within that. So today, it is in every cabinet level agency and every single network. In the commercial world, people use it for things like website search within an application. They use it for monitoring of all the things, cloud things, Internet of Things, observability. It's kind of known as IT, observing all things IT. But not just that, right? Also geospatial things. Uber and Lyft are built on top of Elastic, so that's like geospatial data and operationalizing it. And then security, pretty big play in security. That's where I fell in love with Elastic and was exposed to it. I was doing hunt operations and trying to find adversaries quickly, and it turned out that a search engine was really good at that. In the commercial world, obviously, it's most of the companies and things on your cell phone today. We're the tool that sits behind that enables search in many facets, temporal, geospatial. You use search in almost every app on your phone today, and we're pretty dominant in that space commercially.
Yeah, I think that's the secret sauce. Not many people understand like search is part of everything. Where like maybe some programs in DoD that you're in today, or you're in, and what you're actually doing, or who you're replacing, or roadblocks that you're still seeing in the government, things like that.
Yeah, it's been in my previous role, I was Elastic cybersecurity evangelist, advocate kind of role globally, right? So I just got to talk about how Elastic was being used for many years before we had a SIM UI and a solution around security or had acquired Endgame, but people were already using us. Large organizations like USAA as a bank would be a very well-known public reference, right? Or what I was using it for hunt operations and incident response. But programs that that are come along now as Elastic's matured, and now they have a solution, a UI, and an experience out of the box. But there's a long history there, and I kind of talked about as we entered that market formally, and that's what it's been like over this last 2 years, is true blue out of the box kind of a solution. And so organizations that I can think off the top of my head that are known would be like DISA SIM 2.0 is definitely along that to replace multiple competitors. I'd rather not talk about the individuals, but competitors you would know in the observability and security and logging space, SIM space type world, replace those. Other programs like CDM would be another pretty big public one within DHS, right? They have all these entities that all have various logging solutions and et cetera at every org, and all of that data bubbling up into Elastic and providing visualization for continuous monitoring across all of that infrastructure. And then I'll use one example on my patch. So Army endpoint security system. The Army was very innovative, went out to industry and said, hey, we want to do this as a service, manage our endpoints for us. And so Elastic is behind many of the OEMs that people interact with every day. You just don't know it. Again, we have a long history. So we're behind some of the OEMs that sit in that solution today. And then I think it's 10 or 12 different technologies come together to provide endpoint security and reporting. All of those go into about 5 data centers globally and create this mesh that provides high-level visibility reporting on all things endpoint, intelligence enriched, vulnerabilities, where malware and AV breakouts are, and then enables them to search for the anomalies and things that they're interested in. And that's a very innovative program for sure. And Elastic sits behind it in multiple ways.
Can
Kevin,
you explain? Oh, go ahead, Mark.
I'm not as familiar with Elastic as Jim is, and you are obviously. Why is Elastic so flexible to do all these different things? You're pulling in any different kind of data source and able to search through those data sources?
I think first and foremost, we all came from a world of RDMS, like relational databases, right? And so that's the way data was stored, and that's the way we reported and built visualizations, and that's great. But inherently, and they have their place in the market, to be very clear, but inherently Elastic is a search engine, which means it has to have a distributed nature, right? So it's a distributed architecture, meaning you can lose a node in a distributed architecture and things still work. And there's a lot of tolerance in the communication. So we work really well in like a DIL environment, which solves a lot of problems. If a node is unavailable to answer a question, it just kind of shrugs it off and says, hey, I can't answer that question, but these guys can answer their questions, and I'll let you know when I'm back and available. And a lot of traditional backend systems sort of they kind of panic, right? And that's a big differentiator, a big part of why Elastic is seeing the adoption it is. And then the other one is, because it's a distributed system, we can embed functions at the edge where the data resides, like machine learning, applying machine learning at the edge, versus traditionally we've always had, right, Mark, pull data back. Now I need bandwidth, I gotta have good connectivity, I gotta have a place to store the data multiple times, and then do analytics, and then a couple months later spit out magical answers, right? We kind of changed that model almost unintentionally, because we're search engine distributed. We can embed some of those things closer to the data, as we like to say, bring the question to the data. That could be to help build a visualization, or it could be doing learned or unsupervised machine learning models. It just depends on what the use case is.
So are you a competitor to the data lake, data layer business?
I think we have a role in that. Often, I call them data swamps, no offense. But I think as an industry, we spent a decade trying to put all this data in these, storage platforms and then run analytics on them. And we needed a whole bunch of people with PhDs, and we needed massive amounts of storage. And I think functionally, a lot of businesses, in particular, in my experience in the Fortune 500, my last role, was hard to operationalize, hard to get out the magical answers that we were hoping for. So when you have those environments, Elastic is a great speed layer on top of that, which is a problem, right? For them, there's a lot of problems with that. You got to get the data into a format, you got to get the data in one place, and then you got to know the right questions to ask, and then it takes a long time. And so Elastic has a role sitting on top of those systems and being a speed layer, so you can get actionable real-time answers to things. And so on the competitive side, there's often, when they start learning about the capabilities, it makes you relook at things and think of it less as a data lake and more of a data stream. And how can I interact and do things like speed up an OODA loop live in real time with data? There's a little complexity about how that's done, but it's a different way of looking at data, treating data differently than putting it in a big pile and then doing something with it, when you can just do something with it right now and take actions.
And you don't care about the schema, the various schemas that are across all the data sources in.
This is one of those like little things that becomes a huge thing. If you talk to any PhD in the data science world, they spend 80% of the time munging data, right, or getting it in the right place, so then they can munge it. Like, this is the problem, right? And probably why I think a lot of big data lake projects failed. We spent a lot of money, and most of them were pretty unsuccessful. I think there's some examples in DoD that I won't call out, but they're out there. So what we did as an open source project, an Apache 2 project, Elastic, it said, not only are we going to start to define the way you describe certain data. So a good example would be, how do you describe a person? a username, right? You could do first out last, you could do first name spelled out, last name spelled out, you could do first underscore last name, like you could do Mr. and you could embed it. There's just 100 permutations of how you describe a human being. Take that to a source IP address, a geolocate, like everybody's got 100 ways to describe everything in their logs. So what we kind of said is we're going to define how we describe these entities, and we're going to provide a description and their meaning. And then as data is brought into the Elastic Stack, multiple ways to do that. We don't really try to own or drive that process on how you get data in. We have lots of tools to help, but we're open source in our nature and communal, and we convert it into a common schema. And what that enables you to do across time is as a mission requires or a business need changes and you change out a vendor downstream, it then doesn't, and you put a new vendor in, it doesn't then break your analytics. It doesn't break your machine learning, right? So that common schema has kind of kicked open the door to do things like having a detection engine that can look for cybersecurity threats and anomalies, even as your data sources are changing. And the last point I'll make on it is what we didn't define, we provided kind of a rules for the road on how to extend our schema. And again, it's open source and we're getting a lot of feedback from the community, and it's being adopted really fast because Elastic's pretty pervasive in the world and the open nature of allowing input to change it. So I hope that answers the question.
So you're saying the community is extending the schema through your structure?
Absolutely, all over the place with various customers. You know, one I could think of, we didn't do anything with threat data, threat intelligence kind of information. We didn't have a schema that defined how that. Now, lots of people are using us. In fact, a lot of the tip vendors, right? The intelligence platforms that sit out there where you're gathering threat feeds and you're weighting them or adding your own intelligence for an organization. You have one place to go. Many of them were using Elastic as their backend, right? But we didn't define it in our schema. Well, we had a pull request from a warrant officer in the Army that said, hey, we're using threat data in Elastic and we took your schema, and we think this is how you should do it. We adopted that. And then, I don't know, 6 months later, we started releasing integrations with all the threat providers out there. And we keep, it's like, I think it's like last 3 releases, we've added 1 or 2 more, and I know there's more coming. So that's the nature of how this drives innovation.
Yeah, maybe, I mean, what I hear is this bottom up, you know, the idea of open source was a little of a culture shock because we're used to top down and, you know, this bottom up mentality, right? You get engineers and developers using it, and sometimes the management doesn't even know that that's part of the solution. But again, to get something operational quickly, and maybe you can tell a story like, you know, with the rocknsm.io project, right? That you had no money and you just got something to work.
Yeah, I'll definitely, you know, touch on that, Jim. But I think, you know, stepping back and kind of digesting what you just said there is, for a long time, the commercial market, the DoD, everybody sort of waited for industry to provide an answer, right? And in cybersecurity in particular, I think that really hurt us because we're held back by vendors and their solutions and their ways to get after adversaries. And it's like we kept spending more money and losing more ground. And eventually we stood up Cybercom. Like that was the DoD's, like, we have to get serious about this threat, right? And so in Elastic's approach, it kind of empowers, to your point, people to not wait on the vendor to build a solution. I've got this open source, open and free solution where I can kind of build, tinker, solve my problem, get others' input to that, and maybe move faster than a vendor. And I think that's what you saw when you mentioned RockNSM, which was an open source project. We had found this search engine. We were putting data into a competitor. We couldn't afford the competitor. We had no budget. So we said, let's take this open source project and bring in network metadata, passive network collection through Bro at the time. It's now Zeek, but back then it was Bro. Bring in endpoint logs, get them together, get a better picture of what's going on, be able to ask questions of this data. And it became widely, you know, really popular and adopted by all sorts of organizations. But at the end of the day, we just started solving a problem, and now others came along and appreciated that and used it and contributed. And that then spurred what? An OEM, Elastic, to go, hey, this is a serious market. People are using us all over the place for this, not just little projects that Kevin Keeney and his team are, but major OEMs are embedding us in the cybersecurity solutions. Maybe we go after that. And I think that's when you saw us start making acquisitions. I mean, We've made 2 more or announced 2 more just this month, right? In the security space.
So you're basically the Red Hat of this open source capability, right? You're supporting and evolving the open source. Is that correct?
Yeah, absolutely. It's similar model. There are some nuanced differences in it, but when we started, with the open source project, it very much went that traditional Red Hat path. You could buy some consulting, you could buy some access to support, but then very quickly we started developing commercial IP to add value on top. And I think we were kind of early days to that. Now that's kind of the norm for open source based companies, but we were a little early to that model, I think, and I think executed very well. Part of the reason why I was willing to join Elastic is making commercial proprietary things that solve needs for customers that was very specific, like the DoD. So there's a lot of things that were built in the Elastic Stack early days. Some of the original IP was around FIPS 140, was about role-based access control, attribute access control, field and document level security. These are requirements that came out of the IC and DoD, and they weren't exactly necessarily relevant to all of open source. And we had to put a lot of manpower and engineering development to do it. So it makes sense to make that like, oh, if you subscribe, you get access to all these extra things. Obviously, now that has grown, to hundreds and hundreds of features. But one thing that's cool about Elastic, that's unique, that's not found in everyone else in open source, is we're transparent about that code. Not every single bit of it, but the majority of it. Even the proprietary code, we actually release in public repos for people to see, which is that we call it code transparency, but that drives up security because now people can look at and identify and get paid, by the way, when they find those vulnerabilities. Most companies do that nowadays. So now you're seeing the problems with your own watch as you're building it. And I think that enhances security. It's again, different approaches. We don't have all the answers. We're not going to all get it right. We're going to fail too, but you're going to help us figure that out and move faster. I think it's just a different approach.
How big is the user base for Elastic?
Oh boy, that would be difficult for me to answer. There's probably some investor, ir.elastic.co. You can go there and hear the latest quarterlies, and they can tell you all those official numbers. But I'm probably not the best researcher.
You're still growing at a pretty good clip with new subscribers and larger subscribers. Can you maybe help explain? In the old days, everybody used to charge by how much data you were ingesting. And then the model changed to how much data you analyze, but there's been a struggle in the government to, what data do you want to analyze? Or, there's this thing called index lifecycle management where, some data is hot, some data is warm and cold. And can you just maybe experience like getting the Navy, for example, to understand like what data do you really want to analyze on the ship, or what security data do you really want to analyze? So maybe just talk about that a little bit.
Yeah, absolutely. I think it starts with open source roots, but really you could, even as an open source company that then charges for support and all the things, you could align to industry norms. So in the search world, that would be, you could pay by query, how many times you query, or how many documents you index, or user-based pricing. In share knowledge management, you want to search your SharePoint, Office 365, you want to search your GitHub, and you want to provide your workforce a quick access to that data. You could charge by seat, would be an example. So Elastic doesn't charge any of the ways I just described. Within observability, for example, Jim, APM, application performance monitoring, people would charge by agent, or logging, it would be by ingest pricing, or events per second, you'll see. Or metrics could be by host, number of things, containers, servers, VMs you're monitoring, right? We don't charge that way either. I'll wrap this up, but in Elastic Security, most endpoint, I think every endpoint vendor pretty much charges by the number of endpoints you're providing malware protection on, or ransomware protection. Or in a SIM, back to that sort of log ingest or amount of data you're keeping. We don't charge any of those ways, which is very disruptive. And I think fosters a good, healthy conversation with customers, meaning we're not going to tax you sort of in all of those ways. Our model is simple. Every node of Elastic is going to be a licensed node. That's by 64 gigs of RAM. But then we kind of put back in the customers in the seat to determine how fast do you need this data. So industry uses a thing called index lifecycle management or tiering, and we call hot, warm, cold. And I'll get to frozen in just a minute to answer this question. But our hot does things that most people are not interested and don't need. This would be things in the weapons world, I think, where you're doing real-time fraud interdiction for the banking industry at massive, tens of gigabyte speed across a global infrastructure of a dozen data centers, and you're stopping transactions in flight. That's the kind of hot we're talking about. Not normal, but in the weapons world, there's uses for this, right? So just want to know we can do that. What that means is we're keeping very little data, but and a certain amount of RAM, and keeping that ratio tight. And then we allow the customer to determine what that is. And then as you move through the data tiers, essentially you're increasing the amount of data you can analyze, right? And all the way, you can bring a lot in and dump it on the floor, right? We don't charge for that. That just enables you to enrich and drop and add data on the fly, and then use it, right, for the purpose, whether it's a search use case, an observability, a DevSecOps, it's security, it's logging, it's geospatial for your favorite Uber, type of application. So that data tiering is controlled, that price for performance, and we don't sell observability. We sell license to Elastic. You get that. You get to choose how you want to use the stack. I hope that's helpful. And then the last thing I want to speak to, because it's really innovative and really changing the game, is the ability to take data out of that data tier and move it to like a S3 bucket, a blob storage. You can use Azure storage. You can use on-prem stuff, an NFS share, a MinIO to host your own S3 buckets on-prem, right? Depends on the customer, whether you're operating a SCIF or a tactical environment, right? There's all those different things. And still be able to search that data, which is a huge problem in the federal government, is we have these requirements to keep data for RMF compliance. For me, it reminds me when I was a brand new systems administrator in charge of backups, right? Everybody who enters IT starts there. It's like, where do you start? The requirements, I'm reading the regulation, the Army regulation about how to do this and how long. It's like, I go to the colonel, hey, sir, I need, a 4-drive system, and I need 240 tapes for the first 30 days. He's like, that's all of my budget. I'm like, oh, okay, so we're not going to meet what's in the regulation. We can't. Same thing with data today, is we have these requirements for 365 days to meet RMF, to meet a CCRI, to get through an audit, but no one can afford it. And that's because there's no way to do it. We have now made is the ability to throw it in dirt cheap storage. Yet that once a year, when you need to ask that data a question to pass an audit, you can do that without having to restore and from backups and that arduous process. Which is pretty game changing. I'll give you an example. We had a customer increase the amount of storage by 4x they needed to keep for a year, and the price did not go up by 4x. It went up by 12%. And that's something I'm personally involved in. It's just an example of the kind of cost savings. Pretty dramatic.
Yeah, this new model though is it's a culture shock, because they when you ask them how much data do you have, they don't even know how much data they have, or to understand nodes and clusters and cross cluster replication. It's just a whole new dynamic, right?
There's definitely some time spent educating about modern IT systems and distributed systems and how they work, and how if they're patient and willing to go through the thought process of understanding a new model, they then honestly see increased mission efficiency or faster decisions in the battlefield, and didn't spend more money, maybe spent less money. And that's hard for people to comprehend too. The model's very unique.
So you mentioned ransomware a little bit earlier. Do you actually help prevent the ransomware that's so rampant now in our world?
Yeah, absolutely. We made an awesome acquisition. I was so excited about this. We acquired Endgame. Endgame is kind of came into being out of a need, right? And the need was that all the legacy AV engines out there were all based off of signature policy, kind of like high watermark or low watermark rules. Have we seen this before? Well, as cyber got long in the tooth, they couldn't keep all the bad things, the detections for all the bad things. They created this thing called the sliding window. So basically they're kind of measuring risk across time and assuming the adversary is going to be using, techniques that were developed in the last 18 months. And then the old detections fall off the back. Well, that kind of impacts the Department of Defense in particular in a unique way, because we're not always staying as fresh on weapon systems, for example, right? So that was just very ineffective. And ransomware would be another permutation of that. So Endgame came out of around the same time that like a CrowdStrike, a Cylance, SentinelOne, all of this market shift occurred, where they did learned ML on the endpoint. So they're no longer waiting on a signature, high watermark, low watermark, policy type detection method. They're looking for the behavior of how ransomware works, malware works. And so that's basically been in there since day one. With Endgame, we've now GA'd that capability with the Elastic Agent, where the full kind of coming together of those capabilities and inherent to the stack. And yeah, ransomware is like a turn it on, done. I mean, it's just part of what when you deploy Elastic Agent, it's just baked in.
Yeah, I was actually involved with when Tom Noonan, who was founder of ISS, kind of inventor of the scanner, right? He started Endgame maybe 10 years ago, and they were so far out ahead of everybody. They had a DoD team, but they were doing more offensive stuff, and they had to kind of pivot and wait a little while for the culture to catch up to what they were trying to do. But definitely cool stuff.
That's when I ran into him too, Jim, in uniform. And the old joke was Endgame knows more about what's going on in the endpoint as offensive as red teamers and exercises than the blue team did defending. And I think that's what created the opportunity for the pivot. It's like, hey, this is something,
So in big organizations like these military departments, like you're familiar with, how would they take best advantage of Elastic's technology? Would they deploy fully across their whole department, both the business and mission sides, or what would you think about all of that, how it relates?
Yeah, I think the most common adoption model, Marv, would be you start off with a use case. You need to get metrics on your systems for uptime and health and et cetera. And maybe the tool they have, they can't afford it, end of life, it left the market, whatever. There's a reason. There's an impetus to invite an Elastic in. Somebody downloaded it and tried it, right? And we talked to them. You solve that use case, you meet the immediate need of a department. And then you go, a lot of that data is useful for this use case. And you're already copying another copy of that data over here. You're licensed to use it for the use case as described, which might be just straight up logging, the ability to search for an error code in the logs. And that's how it tends to grow organically. You solve one use case all of a sudden. And as you start solving 2 and 3 use cases, very much a bottom-up approach, Jim, right? Work with engineers and people solving real problems right now. That's definitely our model. And then all of a sudden, senior leaders start to become aware as the spend increases. And then you have a chance to communicate what a distributed data mesh looks like and what the impact on the organization, how they can save money by doing a tool consolidation, bubbling up the pain points of training people on multiple systems, having to implement multiple systems, how to secure them, to train people. Like the costs just start multiplying, and you communicate up. That's how it really takes over very big departments, very big organizations. It just proves itself, and it adds value over time. You're spending more with Elastic, but less on the whole of your data problem, because you're just not keeping multiple copies of it. Would be one straight example, but also just the efficiencies.
What's your biggest footprint in the DoD? Do you know?
The biggest one's probably DISA SIM 2.0 that I can think of. But there's obviously lots of customers that have very big implementations that I just don't feel at liberty to talk about. Sure. That's one I think, everybody knows. It was publicly available, very large contract. But yeah, I think that's, we've got some pretty big ones in the Army for sure that are pretty pervasive. AESS, pretty big. I talked about that one. That's one that's very public I can talk about. But yeah.
It's part of overmatched software armory, Marv, for DevSecOps. So it's part of the DevSecOps stack. Idea being the government eventually will get into continuous monitoring, which they pitch zero trust, which part of zero trust is continuous monitoring. I think there's just a culture shock of the technology is there to really connect and monitor things in real time, as opposed to the RMF process, right? And so that, I think that's more culture and education. But maybe you want to.
Can I take that a step further, Jim?
Yeah.
I mean, we are all focused on the tooling a new tooling and a new infrastructure to implement zero trust architectures, which is great. I'm a huge fan. Spoke at DIU specifically on this topic with them as an advisor. But what are adversaries doing? Adversaries are doing a lot of things, but one of which technique that they're really using is attacking the underlying infrastructure. And specifically, security tools are a target, right?
Yep.
Because if I can get inside of your OODA loop, if I can see what you see, I now know where the vulnerabilities lie. So this data becomes really important. So my analogy I always like to use on this topic is, in the military, you never emplace an obstacle without observing the obstacle. Meaning, if I put up concertina wire on my left flank, I have to have someone watch that, so I know if the adversary breaches that obstacle, now my flank is defenseless, right? So obstacles have a place, but you always have to observe them. That's zero trust. We're putting new obstacles in place. And this is where Elastic comes in, because of things like schema, like we're talking about, Marv. Now we can take the inputs from all these new tools that are establishing this infrastructure, a new way of securing things, but you got to be watching it and making sure that all those things you think are doing their job are actually doing their job, and there's no weird anomalies occurring. And the secondary benefit is that sort of, we got to come up with a new term as an industry, like single pane of glass. But really, at the end of the day, it becomes at least a single place to go look at those different pieces of infrastructure through visualizations, which humans just understand data faster that way, right? At least that's how our role.
Yeah, the solar winds issue, right? We don't really look at logs, even though we collect them all.
Right. Yeah.
So some kind of alert to tell you that there's something goofy going on.
Yeah, you got to interact with the systems that those staffs are using. That could be a Microsoft. When an alert happens, you send it to email might be good, but maybe certain category alerts go to Teams in the channel with the people, or goes into a SOAR platform like an IBM Resilient or a ServiceNow, or right. You gotta get embedded in the workflows of the workforce, right? Yeah, just a dashboard on a wall does not do it.
Or it sends an email to somebody.
Or sends an email. Not just email rule. No one ever checks the thing.
Yeah. Well, even to go back to ransomware, the Scripps Hospital in San Diego there was out for 5 weeks. And that's because the ransomware stayed in there long enough that it was backed up into the system, so many backups that they couldn't figure out where it wasn't backed up.
As they keep going back to they restore, and then it happened again, restored, it happened again. Yeah, that's a great example, by the way, of why you need to keep logs for a longer duration at a lower cost, because we can't just keep driving the cost up and save all the data, because we're creating more data than we ever have. And the proof point I use on that is when I did my first incident response in a cloud infrastructure, we called the provider, who I'll leave nameless, said, hey, we need logs. We know this is happening. They were doing things in Google Drive, blah, 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 or whatever it was, or whatever drive provider it was. And they're like, you have a service with us, we don't provide logs. Like, that's where the industry was, right? Now you will be overrun with logs from those providers. So we can't keep doing that, storing it forever. That just drives costs. So we have to have this ILM thing we talked about. But now what you just described in ransomware is we can go back and identify when that file hits. So now you know the backup job to restore, which again gets us back into speed and efficiency of recovery operations as well. That's a ransomware analogy, but that same analogy can be applied to a public-facing web app, right? When there's a bad piece of code that goes in, to be able to search back and know, okay, this is when our performance dropped. We need to snap back to this point in time when the application was working properly. Because as you know, in the commercial world, this is millions of dollars a minute possibly, but in the defense world, lives could be on the line depending on the apps. If this is part of a kill chain, this is part of a weapon system, we got to be able to remediate that really, really quick, which is all about keeping logs for the right duration and then operationalizing it to execute something.
So if you're a big part of these DevSecOps stacks that are being put together now, where do you see DevSecOps going in the next 5, 10, 20 years?
I'm a big analogy guy. You're already learning that about me, but it reminds me of VMware, right? That's where I think it is. I had friends in commercial industry when I was in uniform, running a data center in the Army at the time, and I was playing with it on a laptop and kind of going, oh man, I could consolidate some things, and this could be really powerful. And every time I talked to my friends, they were taking many more steps. and they were always a couple years ahead, it seemed. I think the same for DevSecOps. I think we realize it's real. We realize the power of containers. We've now got to build the regulation, policy, trails, innovation, just the way it is. And we're in a risk-averse culture in the DoD in many ways. You've seen some people make posts on LinkedIn about that recently, probably. So I think it's just going to lag by a few years until policy catches up. And you got to educate the workforce. The senior leaders need to understand why moving from the way we used to do it to the new way is beneficial. How does this help me meet mission? How does this increase lethality for the US Air Force or the Army? Those cases are to be made and easy. I was at a trade show 2 weeks ago. I was talking to an undersecretary, actually, said, if I could just save 1% on fuel on the platforms that I'm responsible for, that is tens of millions, maybe hundreds of millions of dollars. How can you guys, I know you're doing stuff like this. How can you use predictive analytics? How can you do long-term analysis of data and then make real-time decisions when something's going wrong? And can we shave 1% and save tens of millions, maybe hundreds of millions of dollars? And oh, by the way, things are changing budget-wise. That savings no longer has to go back to the Treasury. It can now fund future innovation. So there are people out there starting to get why DevSecOps can make a difference and save big bucks. So it's exciting.
That is pretty impressive. And so I just, speaking of the containers, I just got exposed to a new term I hadn't been exposed to the other day, because in addition to the Navy guys doing microservices in their S&T projects, this one person was telling us that they're selling functions as a service to be better than microservices. So I guess there's new middleware software that helps tie functions together in some useful way to make that a new paradigm, I guess.
Yeah, absolutely. And another great example of when those functions as a services started standing up, guess what they did? They provided a service, didn't provide any logging. And now all of a sudden someone embeds it in their application. It's critical to making money. They have their first outage and then everyone's hair's on fire and they don't know what's up. So I think it's been 2 years now, Elastic started working with all those providers to capture those logs of as a function. And there's tons of different permutations across all the major providers and be able to log those things. So again, you can provide that continuous monitoring, Jim. You can provide that always ability to look back and identify, is this function operating different on a Wednesday at 2 o'clock than it was all the Wednesdays at 2 o'clock historically,
right?
And just sort of have that baked in.
Yeah.
And when things look anomalous, it's not necessarily a hacker. It means, oh, someone did a pull request and merged some code and all of a sudden it's changed how things work. And that may be the way that tips you off, which might be faster than someone calling the help desk, which is often how we learn things. Is the help desk as a sensor is a pretty flawed model and a little late to the game, especially if mission and lives are on the line.
Well, Kevin, on that, we'll end a great discussion. Thank you so much. Marv, any last thoughts?
No, I think it's fascinating. I'm really glad you brought him up. It seems to me like we might want to get together again in another several weeks or so and carry the discussion further. So thank you very much, Kevin.
Yeah, glad to do it. Cool, great questions. Fun to talk about, where we're at, where we're going, not just a company, as a national security, as a country. It's exciting. Like what you're doing on the podcast. Look forward to following closely.
Thanks, Kevin.